Hello everyone, let's look at another example and we're going to be trying to solve for all of the internal forces in this structure. All of them. So this is like 6 or 7 of your homework problems, so hopefully it helps out. Okay, as always, what's the first step for any of these problems? It's to draw a free body diagram. In this case, I'm not going to redraw this, but I'm just going to turn this into a free body diagram. And so I'm going to have to replace my support, so I replace the pin support with a force in the y direction and the x direction. So I'll call that EY and EX. And I replace my rolling support with a force that is perpendicular to the ground. So we'll call that force Fy. Okay, now with that, I have to solve. Now, how am I going to do that? Well, the first thing that probably makes a lot of sense for me to do is to take the sum of the moments around point E. Got 2 unknowns there, might as well get rid of them. Didn't have to do that, but it works. Is there a better point than that one? No, not really. That's a pretty decent point. So, with that in mind, I can go ahead and start solving. So, sum of the moments at point E. There are a lot of things that have components here, so it's not going to be super simple. And it's going to be equal to, well, I have this one first. So that's going clockwise. We'll say that clockwise is positive. It's going to be 20 times 8. And I have this one, which is also going to be turning clockwise. So that would be plus 10 times 16. This one actually points straight through point E, so it doesn't cause a moment. Okay. And then I have this guy right here, which is also clockwise. So plus 100 times 6, because I only need the horizontal distance. This is a vertical force. I need the horizontal distance. If you want to use the box method, you can. And you'll see the same thing. So 100 here, or actually negative 100, 0, and that would be 6 and 16. And you see that the vertical component doesn't actually do anything, or the vertical distance doesn't actually matter. Okay. Then finally, I have Fy pointing up, going counterclockwise. So that's going to be negative as I've written it this time. 5 times 6. Okay. Wonderful. It's all equal to 0, and so I should be able to solve. Now, hopefully, I can do that. So let's see here. 20 times 8 is 10 times 16 plus 100 times 6, and then divided by 6. 153.33. Okay. So Fy is equal to 153.33. That's going to be kilonewtons. Wonderful. Now I've got 2 more equations. I've got 2 more unknowns, so it all should work out fairly good. Okay, so what other unknowns do I have? Well, I've got Ex and Ey. I'll do some of the forces in the X first. So it's going to be equal to, well, 10 kilonewtons plus 20 kilonewtons plus Ex, which tells me I drew Ex the wrong direction. Who would have figured? Okay, and so therefore Ex is equal to negative 30 kilonewtons. So I'm going to reverse the direction of this. Okay. Then finally, I need to have some of the forces in the y direction. That's going to be equal to negative 100 minus 100, because I got both these forces up here. Then I'm going to have Fy pressing up, which is 153.33, and Ey pushing up. Okay. If you're wondering, if you're going to solve this, it's going to come out to be, I think, 46.67. So Ey equals 46.67. If you're wondering why it's so much less, well, just think about it this way. All of that is kind of causing it to twist down in that direction. You're bending it over, and it's going to be squishing it more on that side because of the moment. That's what's causing that extra amount of force over there. and less force at point E. Well, wonderful. Now we've done that. Oh, I started erasing things I shouldn't erase. I can begin to solve for the internal forces. The internal forces. Now, these are not always easy to do. You need to look for places that look simple. And you're new to this. I get that. So simple doesn't necessarily always seem simple to you. But I'll give you this hint. If you see a place where there's no diagonal members, it's probably simple. Like right here. Well, that one, I have a very simple 3-by diagram. I draw these forces. This will be force EF. This is force FD. And I have 153.3 going up. Question for you. Looking at that, how many forces do I have pointing in the x direction? You have 1. Is there anything else pointing in the x direction? It's not. So sum of the forces in the x equals 0 equals force EF. So that is actually a 0 force member. Now I'll go ahead and write that for us. I'll put 0 right next to this. No force in that. Sum of the forces in the y direction, there's only one unknown in the y direction. That's force FD plus 153.3 equals 0. So force FD is actually going to be equal to negative 153.3. Or that means it's in compression. So those two are really simple. Do you see any other points on this one which are exactly the same? I hope you do, because it's right there. No diagonal members. Nice horizontal and vertical forces. Beautiful. What that tells me is that this one right here is going to be 10 kilonewtons, or 10 in compression, because it's going to have to be pointing back. There we go. And this one right here is going to be 100 in compression. So it works out pretty well. And let's see, is there any other place that would be simple? It's not looking like I'm going to get lucky and find anything else too simple. But we had a good run. We had a good run. Okay, now next I want to make sure I pick a point that will have at most 2 unknowns. So this is going to determine where I'm actually going to pick. So I could do point B, because if you look at it, that would be 1, 2, 3, and I know the 10 at the top. I could pick point E, because that would be 1, 2, 3. I already know the force going to the side. Let's see here. For simplicity's sake, I'm going to choose point E, because simply there's one that's already 0. I don't have to draw it. Okay, so I'll do that. I have to draw my 3-by diagram. I've got 30 going this direction. I have 46.67 going up. I have some unknown force maybe going this way. That's going to have a slope triangle of 3, 4, 5. And I have a force going up, which I'll call force CE. Okay, so that's pretty good. That looks nice. So let's try it out and see if we can solve it. Well, there's only one unknown that's actually pointing in the x direction. So I'll do some of the forces in the x direction first. So some of the forces in the x direction is going to be equal to force ED, but I need its horizontal component. So I take the horizontal component of the slope triangle, put that over the hypotenuse, be 3/5 minus 30. Okay, that's going to be equal to 0. So force ED is going to be equal to 50. Fantastic. Okay, so that is 50. I'll go ahead and write that. That's going to be 50, and it's going to be tension because it's positive. If you draw the arrows, always try to draw the arrows pointing away unless you know the force. And then if it comes out positive, it's tension. If it comes out negative, it's compression. If you already know it's in compression, make sure you draw the arrow pointing towards the dot, not away from it. Okay, now let's do some of the forces in the y direction, because I only have one unknown left. It's going to be force CE plus force ED, but I have the vertical component now, so that's 4 over 5 plus 46.67. Uh-oh, let's do this the wrong direction. And it's going to be all equal to 0. I already know that force ED is 50. So if I solve this, what I get is that force CE is equal to negative 86.67. Okay, so I'll be in compression. 86.67, and that's in compression. Okay. Going good so far. Now I still have 1, 2, 3 unknowns. Which means no matter what, I can't really escape. I'm going to have to do 2 more free body diagrams. That's life. That's life. These problems take a while. There's no way I can cut it either to get all those at once. Oh man, I was hoping that the method of sections would give me a leg up. No such luck this time. Well, I'll cut it right here at point C for now and go from there. So at point C, I have 20 kilonewtons coming in from the right. I have 100 kilonewtons coming in from the top because it's in compression. You have to point it down then. I have 86.67 coming in from the bottom. I have some unknown force CD. I have some unknown force CB. And the slope triangle here would be 4, 3, 5. Okay. Now looking at this, you see that there's only one force that has a y component. As such, I'm going to use that to my advantage and solve some of the forces in the y direction first. So it's going to be equal to 86.67 minus 100, and then plus force CB, but I need the vertical component. So take the vertical component of my slope triangle over the hypotenuse. So it's 4/5. And then that would all be equal to 0. Okay, so if I try to solve that, what do I get? Well, I'll plug in my calculator because that's not what I'm going to try to do in my head. I get 100 minus 86.67 times 5 divided by 4, 16.66. Okay. So force CB is equal to 16.66. And it should be positive, so that means I drew the correct direction. Okay. 16.66, and that's all in tension. Wonderful. And then I have force CD to still solve for. So let's do some of the forces in the y direction now. Sorry, some forces in the x direction. So that would be 20 plus force CD plus the x component of my 16.6 force. As you can see, I drew force CD in the wrong direction. Okay. So what's it come out to be? Well, force CD is going to be equal to 20 plus 16.66 times 0.6. 29.996, which is close enough. I'm just going to say it's 30. Negative 30 to be exact, because it's in compression. Okay. So I'll write that right here as in compression. Well, we're getting there. We have one last unknown to solve for, which is this force right here. Which one should I solve using? There's no real good way about it. So I'm just going to choose to cut around point D. So I have this force BD, which I don't know yet. I have that compressive force of 30 kilonewtons. I have 50 kilonewtons going down. It's got a slope triangle of, based on geometry, 3, 4, 5. And then I have, shouldn't have put that there, no room. silly me. 5. Okay. And then I have a 153.3 compressive load right here. It's compressive, I point it towards the dot. If it's in tension, I point it away from the dot. Never forget that. Okay, so if I'm having to go on a limb here, I'm saying I probably drew force BD in the wrong direction, but I'm going to keep it for now. Now I've got one unknown, it only points in the y direction, so I'm going to use just my y equation. So force in the y is going to be equal to force BD plus 153.3 minus the y component of this 50. So that would be the vertical component right here, 4 over the hypotenuse. And I get that force BD is equal to negative 113.3. So it's in compression. Okay, so with that, I have solved for all of these loads. And hopefully I did it correctly, because there are times where I accidentally get a calculator error somewhere in here. But at the very least, you have seen the steps to take to solve this problem. So I hope this helps you. I'll be doing some more examples, so be on the lookout for those. And thank you for your attention. Goodbye.